Alright, good morning. Let's quickly recapitulate what we have seen last time. Yeah? Anyone? Yeah, so we have introduced sequential memory elements, right? And to be specific, the sequential elements which we have seen last time, where what was so specific about them? What was so special about them? The memory elements, see, we have been seeing this memory elements since last week, right? Since last 3 lectures. So what was so specific about the one which we have seen? Yes. So the very the important point is they operate during signal transitions, or they are edge sensitive. That's why we named it differently, and we named it as a flip flop. Okay, one example we have seen as a we saw that a flip flop actually is constructed from a couple of latches, right? So latches forms basic elements or building blocks for creating flip flops, and we just and also I have given you homework to just find out what difference it makes, isn't it? When the input or the data shuttles in between before stabilizing, right? So I've said that it may consume a lot of power. We don't want those shuttling to happen. We want stable conditions. So we have introduced what was called as a D flip flop, a delay flip flop, or a data flip flop, which consists of two D latches, and one was acting as a master, another was acting as a slave. In the sense, when one was active, other was inactive, and vice versa. We saw that during those activation, okay, the slight edge which was present during that stage, the operation happens, or the data is getting trapped or locked, isn't it? So that's how it is sensitive. Then we have seen after the flip flop we have seen another class of flip flop which is called as a JK flip flop. Isn't it? A JK flip flop, just because it may happen that we may sometimes require to set some output, we may require to reset some output, okay? We may require to toggle the previous output, isn't it? So the very specific thing, okay, or very special thing about the memory which we have seen was, the present state, okay, the present state depends on the present inputs and also the past behavior of the circuit. That's what the sequential circuit is. So till now we have seen. Now let's go ahead and look for what is called as a different. Let's analyze these sequential circuits. Okay. So let me see. All right. Now let's analyze. Okay, so let's begin the analysis of sequential circuits. So it is 14th. It's a special day. So let's analysis of sequential circuits. You may open the windows if you are getting suffocated. Analysis of sequential circuits. Alright. So see, this analysis is simple, like we have seen the truth tables in normal combinational circuits where the outputs were dependent on. Now the thing becomes slightly complicated here, okay, because the current output depends not only on the present inputs but also on the past behavior. So to interpret, okay, these sequential circuits, we have some procedures, or they have some representations. So let's see at what is called as a state diagram representation. So called a state diagram or state transition diagram, you can say, representation. Let's see, let's see with an example.
example. Now consider this circuit. Simple circuit. Let's consider this circuit. Let this be a D flip-flop. Now see, what is this? If I draw a box and write a D there, and the output I write some Q, and here let it be a clock. What is this? What is that? So that edge matters. Okay. Can you be specific which kind of flip-flop it is? A positive edge flip-flop, isn't it? So consider this circuit. Let this be X, Y, and the interesting part about this circuit is we have a feedback. Okay, that's how any sequential circuits would be, isn't it? So let the output be A, let this be a clock, and so on. So we have in the present states, let me write that, we have a present state, then we have input, and then we have next states. And let this be output also. So now what is the present state? So see, I am writing something state in the sense what is the condition, present condition of this circuit, in the sense what is the present condition of this A. Okay, A is the output here, so the present state of A. So let me not write like that. What are the inputs? Inputs are X and Y. Next state is I'm denoting it by A plus. Okay, just it will tell you the next state. Okay, so let me write this also. Alright. Now see, it may happen that we may end up into any present state, okay, and inputs may again be anything. So let's have all the combinations of present state and the inputs. So let's write, so A may be 0, XX, and so on, right? Now let's analyze each case one by one. See here, now the present state. Okay, just look at the circuit first. X is 0. Okay, so let me write. X is 0, Y is 0. What is here? X or Y. What is that? 0 then. So let me first write the equations. Okay. So okay, and here it is X or Y. X with XOR with the Y, and that is XORed with the previous wala A, isn't it? So what is the output, you tell me? Now D is represented as x XOR with y XOR with the present state, right? The present state of A. What is that? 0 0 0. So D will be 0. So as soon as the next clock signal comes, okay, as soon as the next edge comes, positive edge comes, what would be the next state? No, that will be simply, just because it's a delay flip-flop, D flip-flop, it will simply copy that data, right? So it will be 0. Is that okay? Now, okay, let's go for this. 0 1. Rub this. Let this be 0 1. What is the output here? It will be 1. The previous data, what is A? 0. So it will be simply an XOR combination of all these three inputs, right? So do that. 1 1. It will be 0 1 0 0 and 1. Is that okay? Now let's express or represent this, the transitions as a, some kind of graph. Let's do that. So what I'm saying is, how many states are there? You tell me. How many states are there? State may be 0 or 1, right? The next state or the present state, it may be 0 or 1. So let's, I'm representing this with some kind of circle like this. This indicates, a present state or the next state. Okay, it's a state. It's a state. So the state may be 0 or 1. So I'll write inside that 0 or 1. Okay. Then I'll check for the, what is the input. So say for example, present state is 0. Okay, and the inputs are 0 0. What is the next state? It will be 0. That means, I will draw it something like this. The present state is 0. It will go back to the same state when the inputs are 0 0. Is that okay? So this is, what I am writing. See the line which is emanating from this circle is called as a, it represents the transition. It represents the transition from one state to the other. And what I am writing on this, along the lines, is nothing but the input or the output. Okay. So if now see here there is no output. Okay, output may be the same state I am saying, or I may put some combinational circuit here to get the output. Okay, it depends on us. Now time being, I am simply representing the input. There may be outputs also. If there are some outputs, let me write y equals to a here. Time being, let this be output. Okay, then I will write a slash and say that okay, the output will again be that is as good as a or equal to a, that is 0, and so on. Okay, so what I am saying is the representation is there is a circle. Inside that I will write a what is the state. I'll draw a line emanating from that circle showing that what is the transition. I'll write the inputs and slash followed by an output. That's how the representation would be. Okay, so let me complete that. So it is 0 0. The inputs are 0 0. That the x and y are 0 0. It will remain to the same state. Then let's go to the next. What if it is 0 1? It will go to the next state. So I'll write that. It will go to the next state when the input is 0 1. Is that okay? When the input is 0 1, the next state would be 1. So 0 and 1. So the circle only represents the state, and the lines emanating from that represent the transitions. Then go to the next one. 0. Okay, the present state is 0, and if it is 1 0, then it will go to 1. 0. It will go to 1 when it is 1 0. Is that okay? Okay, this third case, third row, this one. Then you go for the present state is 0, the input is 1 1. What it will do? It will still remain in the same state. That means it is as good as 1 1 here. Okay, you can represent it with the comma. Next, if it is 1, the state is 1, it is 0 0, it will remain to 1. Should I write it like this? Is that okay? When it is 0 0, right? This is okay. Then when the input is the present state is 1 and it is 0 1 at the inputs, okay, it will go back to the it will go back to the 0 state, right? That means okay, so I am representing two arrows here, so I can also write I can rub this and merge it into one. so that the one can be utilized for the 0 to 1 transition and other for the 1 to 0 transition. So what was here? 0 1 or 1 0, is that okay? And here from 1 to 0, okay, it goes from the 1 to 0 when it is 0 1, right? 0 1 and also 1 0, is that okay? From 1 to 0 when the present state when the inputs are 1 0, and it will go to the next state as 0. So this arrow indicates the transitions. Is this fine? Now so this kind of representation, now this is a kind of this such representation is called as a behavioral representation. Okay, now what is this representation? This is called as a structural representation. We specify that okay, what is there at the output, what is there at the input of this D flip-flop. We specify that okay, it's an OR combination. So while specifying that in the program or in the description, what I will write is I'll simply write this D equals to X XOR with Y XOR with A, something like that. But say for example, I don't worry about this. I simply leave this to the software or the computer to manage it. Okay, what I will simply remember is this one. Okay, its behavior, how it behaves. Okay, just because while specifying when the client specifies any specifications, he'll simply he'll be simply interested in what will happen or what will be the output, what will be the next state when some inputs are there. So what he will give is some kind of behavioral description. He may not know what would be the structural description. That has to be left with the software. So what the softwares which we are going to learn in the subsequent sections is what the softwares will do. If you give the behavioral description, it will automatically optimize such circuit and give it to you. Okay, so you don't worry about what the circuit is. You just are worried about what is the output. Okay, we want such kind of output. That's it. When the specific inputs are given, we want some kind of output, something like that. So that's why it's called a behavioral description or a state transition diagram. Okay. So this topic is quite important. In recent 2017 GATE examination, it was asked for 2 marks. Okay, this is only two दो transition हुए इसमें बहुत सारे transition और बहुत सारे states थे. Okay, so there was one question in 2017 exam, and there were in the previous GATE examinations also there were a few questions based on this. All right. So apart from the exam, it's it's a quite important topic. So let's go for some another example. All right, so let's see this one. Take another example. I'm taking some standard examples. Now see, when the circuit is big, you have to be very careful. Which kind of, what is this? You tell me. What is this? Latch. What is this? A flip-flop. What kind of flip-flop, to be specific? Toggle flip-flop. What kind of? Yes, positive edge toggle flip-flop. Okay. AND gate. So let this be output. As I said, the output may not be the current states or the next states. It may be a combination of the states. Let this be A, B, QA, B X. Let this be X. There is only one input here, and the clock. Alright. And we assume that both of this clock or both of the flip flops get triggered by the same clock. Okay, that's important. Okay, let's try. Alright. So whenever a circuit description or a structure like this has been given, okay, the first step is to note down how many inputs are there, how many states are there, how many the present states are there, how many the post states or the next states would be, and how many outputs are there. Okay, so first you should always form a table starting with what is the present state. What are the present states? States equal to number of flip flops. Okay, how many number of flip flops are there? 2. So there will be 2 present states. Okay, let us write that. So it will be present state so it's A and B. How many number of inputs are there? Only one. X is only one. Okay, only one input is there. Okay, only one variable. Others are simply connections. Okay, so X. What are the next states? A plus, B plus. How many outputs are there? Only one. Okay, these are the states. Okay, the output, the next states we have represented, but the output may be a combination of this, and output may be some different configuration also. So only one output Y there. So let me draw this. Can you complete this table quickly? Complete this table. Try to complete this. So this is the first step. The next step you should remember is first you may calculate intermediate outputs also. Okay, what you may do is you can simply note down what is here. What is here? What is here first? You tell me. B, right? And here X into B. What is here? Okay, that's the clock. What is here? T. यहाँ पे X है ना? Output बोलो यहाँ पे क्या है? B A B ना? सिर्फ A B रहेगा. You should mind that we are now this is the output means the current output. Okay, the present output you can say. Now let me write that also. Okay, present output. Okay, because we are interested in what is the output right now. Yeah, complete this. First of all, how many combinations would be there again? 0, 0, 0 and so on. Alright. So, when the input is 0, 0, okay, and when the input is 0 and the present states are 0, 0, okay, what is the output? You tell me. What is the output? What is the next state first? What is the next state? Okay, so the previous state is how much? 0, right? So यहाँ पे 0 लिखूँगा. What is the input? 0. So it will become 0 here. Okay. So what is the here? X. X is again 0. So when the next clock signals or the next positive transition comes, the state would change. Okay, the state would change. But what is the what is the there at this state? What will be the next state? Toggle na. T flip flop means what? When it is 0, what is the truth table for T flip flop? Turn your pages. When it is 0, the earlier states remain unchanged, isn't it? Isn't it? When it is 0, the input to the T flip flop is 0. The state remains unchanged. When it is 1, it will simply complement or toggle the output, right, the previous state. So what is the previous state here? AB is 0 0, so it will remain as it is. Should I write that? 0 0. Okay. What would the output? Now output, as a present output, it depends on the present states. Okay. Now this is the next state, next wala state. But what is the current output? It depends on the present state. What is that? Is that okay? And of it is equals to AB, right? Complete this. Complete this. Yes, please. Yeah, when I'm saying next state, when the next positive edge will come. Okay. I'm just predicting what would be the next stage if the positive edge of the clock signal comes. Here there is a clock. Okay. The next state would come when the next positive edge would come. Alright. Can you complete this quickly? Do that. Yeah, next. 0 0. AB is 0 0. Okay. So here it will be 0 and A is let it be 0 0 here. Yeah. So the input is X is 1, right? So what is here? Again 0. What is here? X is what? 1 here, no? यहाँ पे when the next cycle would come, when the next positive edge would come, what will become the next? No, what is the the output would be? What would the next state? No, if there is a 0 at the first toggle flip flop, so state will remain unchanged for A, but it will toggle for the B, right? So it will be a complement for B. So let me write that. So initial state of A is retained, but B is toggled, right? Is that okay? And what is the present output? What would the present output? Fine. Complete this quick. Okay, I should not write. So you do it. Okay, do it by yourself. Let me see how many of you are able to do it. You have to be very careful. Okay? Analyzing those sequential circuits, you have to be very careful about the states. You are not getting. me write, verify your the states. You should get something like this. One. Are you getting these states? 1 0 1 0. 1 1 1 1. Bolo next. Yes. Tell me the outputs here. All 0. यहाँ पे 1 1. Is that okay? Draw the transition diagram. Draw the transition diagram. So now see here. How many states are there? The states are there are 2 flip flops, right? So 2 flip flops may have 4 different combinations. So there will be 4 different states: 0 0 0 1 1 0 0 1 1. So draw state diagram for you'll have 4 different circles like this. Yes. Which one? Okay. So yeah. So let's take any case. Okay. Let's take any case here. Okay. You tell me which case you would like. Second and last now. This one. This is okay. This is more interesting. Achha, last. Okay. This one. Last one. Okay. What is the present state? 1 1. Let me write that 1 1 here. 1 1. This is the present state. Present state in the sense what? When I'm when the clock is not arriving, okay, when the circuit is in stable condition, okay, that is what the state, okay, that is what the present state is, okay. When I'm not applying clock, just before arriving the positive edge of the clock, what is the the condition of these flip flops? Okay, it is 1 1. That is what has been given. Okay, that is what we are analyzing. If the states would have been 1 1 and the input have been 1, okay, input have been 1, input here x, let it be 1, okay. What is the output here? Now B is the the previous wala state. It will also just because they are connected, the B equal to 1 will also reflect here. What is the the output here, okay, of this AND gate? It will be 1 here, okay. And what is the input here to the next flip flop? It will be 1. Now this is the condition just before arriving the positive edge of the clock, okay. That means this condition is there when I am drawing this clock, okay. Just before this positive edge, okay, just before this, okay, यहाँ पे ऐसी condition, okay. As soon as the positive edge comes, okay, as soon as just because these flip flops are positive, the edge triggered, okay, and that too a positive edge triggered. The changes in the states would happen only if the edge comes, the positive edge comes, okay. As soon as the positive edge comes, it will check the present input, okay, to these flip flops. What are those? 1 1, okay. What happens when the toggle flip flop is having 1 at the input and the clock arrives? It will simply complement, isn't it? It will simply complement. That means the next state would be a complement of the previous state. The next state A plus. Okay, the next state, that means as soon as the clock comes, the flip flops would change the state to what? Okay, it will toggle to the previous state. Previous kya tha 1, it will toggle back to 0. Second flip flop is also having 1 as the input. The the clock is synchronized. As soon as the positive edge comes, it will also stop. Okay, and the output is actually dependent on what is the present. I'm saying that it's a present output, so it depends on A B, not A plus B plus. Okay, that would be the next. We don't have to do anything with the next. Okay, we are just bothered about the present output. Okay, so that's how it will be. It will be 1. So it won't be 0. Okay, it won't be 0. It will be 1 just because it's a present output. So what is the present state? 1 1. So it's the AND of 1 1. So it will be 1. Is that okay? Is it clear? So let's draw the transition diagram here. Tell me what would be the states? 0 0, 0 1, 1 1, or now we don't need to go for gray. Okay, so 1 0 and 1 1 is fine. Alright, so can you tell me now when it is 1 0 0, let's go row by row. When it is 0 0, input is 0, it will remain in the same state and the output will be 0. Okay, see here, should I write like this? Okay, it is in the same state. When the input is 0, output is also 0. Is that okay? Alright, now see what I am saying is now let me draw this completely. When it is 0 0, okay, let's take the second row. When it's 0 0, input is 1, it will go to 0 1, it will go to the next state, and the output will be 0, okay, and the output will be 0. So this will, should I write it like that? Okay, 0 0 is the current state. When the input is 1, output will be 0. Is that okay? But the state would be changed. So you can interpret it like this, okay. When the state is 0 0 and you give input as 1, the output will definitely be 0 at that time, at that present state, and the state would change to 0 1. So that is how you should interpret, okay. But you don't have to bother about what the next state would be. The output depends on the present state. Okay? That's the important point to be noted. All right. So let's complete this. So the third one, when it is 0 1, the input is 0, the output is also 0. It remains in the same state. Is that okay? Then 0 1, when the input is 1, it will go to 1 0. What is the output? Oh sorry, what is the input here? 1 0 ka input? 0, 0 is done. So 1, it will be 0, right? When it is 1, this, oh sorry, this one. I'm sorry. When it is 0 1, the input is 1, it will go, it will change the state, right? When the input is 1, output is 0. Is that okay? Is this fine? Then which row? 0 1 ho gaya? 1 0, yeah, 1 0. When the input is 0, it will maintain the same state. Input and output will be the same. 0 0. Next, when it is 1 0, when it is 1, it will go to the next state and the output will be 0. So is that okay? 1 0. Then 1 1. Tell me 1 1. It will maintain to the same state. But when the input is 0, output is 1 now. Okay. Similarly, the last state, go back to the original state. It is 1, and the output is also 1. Now, is this fine? Are you getting this diagram? Correct? Okay. Now, let's take one more example of this. All right. Yeah. Consider this circuit. Now I am drawing somewhat big. D A 6 o'clock here. Draw the circuit. DB D clock. X. There is something special about this circuit. slight complication here. So the notations would be, when I'm emphasizing it, okay, dot is like bold, then there is a connection, okay, otherwise there is not. I'm not drawing the jumpers. So there is no connection here, okay, there is no connection here, okay, unless otherwise this this bold is there, there is no connection. It's fine. Okay, let me verify. This is input. Alright, so this is fine. And assume that the clock, they are synchronized with the same clock signals. Okay. The case would be different if they are not synchronized, okay? Now there is something special about this circuit. Can you notice, you go through the previous two circuits, check with this circuit. What's so different about this? Yeah. So you should say that the output is not only dependent on the state, the present state, but also on the input. That wasn't the case earlier. So such kind of such kind of this circuits, or the such kind of sequential circuits are called as finite state machines, or FSMs. Okay, and in the case where this input is also involved in the output, it's called as milli FSM. MEALY. So that's what scientists name. So milli FSM. And the earlier circuits are called as Moore FSM. Okay, MOOR. When there is no inputs involved, okay, when the output, the next state is depend only on the present state, such kind of FSMs or sequential circuits are called as Moore. Okay, Moore FSM. Okay, finite state machine. And where the inputs are involved, that's called as milli. So can you tell me how many inputs are the first step? Step 1, bolo. Step 1 is to find how many number of inputs are there. How many number of inputs? Only one. Tell me how many present states would be, just because two flip-flops are involved, okay, two storage elements, two states, okay. How many combinations? 8 combinations. How many outputs are there? Only one, okay. Draw the characteristic table and find the behavior, and also draw the transition diagram. Do that. Quick. While predicting the next state, okay, you have to be careful. You need to observe which flip-flops are being given. Okay. Not necessarily always there will be D flip-flop. There may be any flip-flop. Okay. Maybe any flip-flop. First thing you should do is to write all the combinations of inputs and the present states, and then predict the behavior depending on what is the circuit. Okay, you may write intermediate values. Okay, so the simplest thing would be you break down this circuit into small pieces, and do analyze it part by part. So what is the output here? You tell me, it's AX. What is here? BX. BX. Here it is X. A or B. Is that okay? What is the output here? So this is A bar. Should I write it A bar? What is here? What is here? X A bar. Now analyze it part by part and then draw the transition. Quick, do that. काफ़ी दिनों के बाद याद आया कि मुझे अटेंडेंस भी लेनी होती है, सो आई विल टेक द अटेंडेंस टुडे. ओके, या प्लीज, यू आर ऑन द राइट टाइम. हाँ, input is always the present I am saying. Okay, the present state. You should always say present state and next state. You check now. I mean, before the clock arrives, okay, what is the output? You tell me. Present wala state, right? It's always the case. You need to complete homework for you. All right, you may be quite surprised when the attendance was displayed, that सबका जो attendance था, you may be surprised that जब आप थे भी नहीं तब भी present की mark की गई थी. Okay, so before sessional 1 everyone was present, so that's a thumbnail. So after that, so let me mark the attendance first. Parth is here. Mayur, Divyesh. So I may increase any number of ones here. Okay. So Atharv, Tushita, Nilay, Aisha is here. Kunal is here. Dinesh, Sanket is here. Rinisha, Sanket Kade, Vaidya is here. Braj, You should not claim if you are not present here and I'm marking, you know, lot of absence. Okay, you should not claim invalid inputs, indeterminate state. So yeah, Sakshi, Kachita, Vaibhav is there. Yeah, Aman, Divyashri, Shravanti is here, Shiv Kumar, Saurav, Tejas, Arun Kumar, very good. Sunny. Alright, important announcement for you. How many of you have checked the website? So, you know, the registration form is out for for the course project. It's compulsory. You need to register with, you know, each group must have, you know, maximum of 3 students. Okay, you may go for individual projects also, no problem. Then you need to click here, fill the registration form. You should write the instructions carefully first. Okay, we are planning to have it on 24th. Okay, don't give any free slots on 24th of March. Okay, we are planning to that. The exhibition may prepone or get postponed. Okay, it depends on, but it will definitely be in the last week or last but one week of the May. Okay, the 24th मतलब यहाँ पे ये इस वक्त ही रहेगा. Okay, 24th ये last but one week of this May, between 19 to 25 definitely we are going to have these exhibitions. Okay, you must, the last date to fill up this form, after that it will be deactivated. The last date to fill up this form is, you know, by tomorrow. Okay, if you need some more time, I'll extend it to one more day. Okay, within 2 days you need to fill up this form, because I have told you, this is from, from many days, isn't it? बहुत दिन से बोल के रखा है, तो you take 2 days, you spend some significant amount of time on this. Okay, and I have given all those instructions. You need to fill this, after which it will be deactivated. In this you need to put contact email ID. It should be only for one person per group. Okay, सबका लिखते मत बैठो. Contact number of only one person per group. So only one volunteer from one group. And you need to fill the names, enumerate it. One, you write your names in bracket. You should write your roll numbers and so on. Title and a clear short description. भागड़ कथा लिख के मत बैठो. एकदम clear. 2-3 लाइन में एकदम जो output है वो लिखना चाहिए. उसके बाद you simply submit it. Okay. Your project may get approved, may not. Okay. So after 3 days, 3 to 4 days, by the end of this week, you will come to know your project has been approved or not. So better to come up with a project which will definitely be approved. So what would be the guarantee? Matlab, it should be beneficial somehow to the humans. Okay. So it's like a tagline of Samsung, made for humans, something like that. So that's how it should be. Okay, that's what I expect. So let's stop here.